Continuing on with question number 6. These are mole conversion problems. You might want to use your mole map. Here's a quick version of it. So if I have moles here and I want to go back and forth to say grams, I'd use the gram formula weight. If I want to go to molecules over here, or I'm just going to put particles. Particles could be molecules or formula unit, or it could be atoms. And if I want to go to liters, go down here. So you go to back and forth between moles and liters, you're going to use that 22.4 conversion factor. There's 22.4 liters in a mole. You go back and forth here, you use Avogadro's number, 6.02 times 10 to the 23rd. All right, there's a decimal point right there, which is always a challenge for me using this pen. There we go. All right, so looking at this one, you got 50 grams of calcium carbonate, and you want to go to formula units. So you got grams, you go into particles, because the formula unit is a particle, it's a piece of it. So first we go to moles, and then we go to particles. So 50 grams calcium carbonate. You have to write the chemical formula correctly. So that's plus 2, carbonate's minus 2. So once again, plus 2 and minus 2. And that's positive 2, and this is minus 2. All right, so continuing on, you're going to put grams of calcium carbonate on the bottom, moles of calcium carbonate on the top. 1 goes with moles in these conversion problems. 1 always goes with moles except in the mole ratio step of stoichiometry. This is 100 grams of calcium carbonate here. I get that by using 40 and 12 and 16 times 3. So I'm going to quit adding these weights. By now we should know how to do that. Remember up here we just did a couple others and you've been practicing on those. Okay, then you're going to put moles of calcium carbonate on the bottom so that it cancels up here. You're going to put formula units on top and use Avogadro's number, because when you're going back and forth between moles and formula units, you use the 6.02 times 10 to the 23rd. Then to do the math, it's 50. Oops, I put that in the wrong spot. Let me erase that. All right, so this should have been 6.02 times 10 to the 23rd on the top, and 1 mole on the bottom. So then moles cancel. You have 50 times 1 mole times 6.02 times 10 to the 23rd, then divide by 100. In case you're wondering about the calculator, you type in 6.02, then EE, then 23. Never do you hit times 10. So your final answer on your calculator will say 3.01 E23, which means 3.01 times 10 to the 23rd. Okay, down here, number 7, 25 moles of magnesium nitride. Notice I'm putting Mg3N2 because nitride means plain element. That's plus 2, that's minus 3, so you got to have a common multiple of 6. So 3 atoms of magnesium makes 3 times positive 2 is 6, and 2 times negative 3 is 6. All right, so down here you're going to put moles of magnesium nitride. And on the top you put grams of magnesium nitride. Turns out that the formula mass of that is 100 grams, 100 grams per mole. This is only a one-step problem. So you're starting with moles, you're going to grams, so moles to grams up here, moles to grams, it's just one step. All right, its final answer would be 25 times 100, which is 2,500. Moving on down, you got 25 grams of iron 3 oxide. So you have 25 grams of Fe2O3. Remember, the 3 means plus 3. Didn't mean there's 3 irons, means it's plus 3 charge. Not 3 atoms, but plus 3 charge. Oxygen's minus 2, so common multiple again. 2 times 3 is 6, 3 times 2 is 6. We're going to change it to moles first. So 1 mole, 160 grams. Once again, you look back at your mole map up here at the top of the page. You're starting at grams, so your grams, 25 grams, starting at grams. You're going to formula units over here. So it's a two-step process: grams to moles, moles to particles. So let's go ahead and finish our second step. We just did the first one. Go ahead and put the symbol in. Then on moles will go on the bottom. On the top will be formula units, and 6.02 times 10 to the 23rd. Once again, do you type in times 10 on the calculator? No. Use EE. Okay, 3 moles to grams. So 3 moles of iron 3 sulfate. So you got Fe, 2, SO4, 3. That's because of the charges again. So that's plus 3. This is minus 2, common multiple. All right, then you have moles here. You have grams on top. Why are moles down here? Because you want to cancel moles. Then on the top, you have the number of grams. I don't know what that is off the top of my head, so let's just add it up. So we got 56 times 2. This time I'm going to add this up slightly differently. I'm going to say that this whole business inside the parentheses, right here, all this, that is 96. And the reason that's 96 is because 1 sulfur is 32. Each oxygen atom has a weight of 16, and 16 times 4 is 64. So 32 and 64. 32, 64 makes 96. But then I have to multiply that by 3. Okay, so 56 times 2 on this side. And then that equals 112. And then if I do the 96 times 3, 100 times 3 is 300, so 4 times 3 is 12, so 300 minus 12 is 288. So if I add those together, you get a 0, carry 1, you get a 0, carry 1, kind of looks like it might be 400. So it'd be 400 grams for every 1 mole, which gives us the final answer of 1200 grams.